Exponential functions. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. The exponential function with base a is defined for all real numbers x by Many students do not understand why we have restrictions on the basis of exponential functions. It's very important that you understand the restrictions. Using 0 as the basis for an exponential function would have two problems. First, if the base a equals 0, we would have f of x 0. It means for any x the function would always result in 0. Second, if the base is 0, the function is undefined for any negative values of x. Using 1 as the basis for an exponential function would have one problem. If the base a equals 1, would have f of x 1. It means for any x the function would always result f of x equals 1. In other words, f of x is just a constant function. Using negative values for the base would have one big problem. If the base is negative, we could have a square root of negative numbers. Using negative base values would make the function undefined for certain fractional values of x. Now that you understand the restrictions of the exponential functions, let's study the main features of their graphs. To graph an exponential function, you need to plot a few points, and then connect the dots and draw the graph. Let's see how it works. Draw the graph of each function. Function f, function g, function f is increasing. Function g is decreasing. Characteristics for these graphs. The domain is the set of all real numbers. The range is all positive real numbers. The graphs have a y-intercept at 0 and 1. If a is positive, then the function is increasing. If the base is between 0 and 1, the function is decreasing. The line y equals 0 is the horizontal asymptote of the functions. Now that we know the general shape of the graph of an exponential function, we can graph other exponential functions. Transformations of exponential functions. If we know how the graphs of exponential functions are translated and reflected, we can rapidly sketch the graph of many exponential functions. The general form of an exponential function is A controls how steeply the graph increases or decreases. H controls horizontal translation and K controls vertical translation. The equation of the horizontal asymptote is y equals k. Let's see how these transformations will affect the exponential functions. Draw the graph of each function. Let's graph the function 3 to the power of x. The asymptote is the line y equals 0, or the x-axis. Domain is real. Range is all reals from 0 to infinity. Now we use the graph of function f to find the graph of the function g. The graph of function g can be obtained by translating the graph of function f 2 units to the right. Pay attention. Domain is real numbers, range is real numbers from 0 to infinity. The graph of a function h can be obtained by translating the graph of a function f 2 units up. Pay attention. The asymptote is y equals 2. Domain is real. Range is all reals from 2 to infinity. Draw the graph of the function f given by. Let's start drawing the graph of a function 1/2 to the power of x. Now translate the graph 1 unit to the left. Then draw the asymptote y equals -2. Translate the graph 2 units down. The domain is the set of real numbers, and range is all real numbers from 2 to infinity. It's very easy this way, isn't it?